This is other excellent question. What is the difference between capacitors and batteries? Because both of them storage energy. The capacitor storage energy and the battery also storage energy. What is the difference between one and the other one? It's no difference. It's a small difference. Both of them storage energy, but the battery produce energy. The capacitor not produce, only storage. The unit for capacitors is capacitance, and the unit is farads. You remember microfarads, nanofarads, and picofarads. The formula, we don't need memorize the formula. This is only for information. You don't need in the future make calculation related with capacitor. This is only for information. Remember, my friends, I want that you be a successful engineers, not technicians. Don't try to disassemble the capacitors because internally you found a liquid and that liquid is poison. Be careful with that liquid. That liquid is poison. Don't try to destroy the capacitors to verify what happened inside. Believe me. The next table is easy to convert in between a microfarad, nanofarad, and picofarad. For example, in this particular case, 1 microfarad here is equivalent. 1 microfarad here is equivalent to 1,000 nanofarads and is equivalent to 1 million picofarads. This is the reference that normally I use to convert from micro to nano and nano to pico. In DC, normally the capacitor is charged maximum until the value of the power coming in. In other words, you charge the capacitor exactly with the same amount of charge coming from the source of the power, no more. And immediately you remove the source of the power from the capacitor starts to release the energy slowly. In other words, if you have a capacitor, AC capacitor like this, and you charge the capacitor with a source of power 120 volts AC, immediately you remove the source of the power and you check with the voltmeter, you have 120, 117, 110, 190, 80, 70, 60, 40, and immediately the capacitor discharges. In capacitors, when you have 3 capacitors connected in series, the total capacitance is equal to the capacitance number 1 plus 2 plus 3, but that total amount is going down. The total capacitance goes down. In series, the total capacitance goes down. In resistor, goes up. Okay, what happens when you connect the capacitors in parallel? When you connect the capacitors in parallel, like this, the total capacitance at the end, the total capacitance goes up. It's opposite like the resistor. You remember when you connect a resistor in parallel with 3 resistors in parallel, the total resistance is less than any of the individual resistors. You remember that? All right. When you connect in series like this, in series, one, the other one, and the other one, the total capacity is down. When you connect in parallel, the total capacitance goes up. Okay, what is the advantage of the electrolytic capacitors with respect to the other one? Those capacitors, they have a big capacities. They can accumulate a big amount of energy. For that reason, they are used for different purposes, like for power supply units, for voltage leveling, and ripple reduction, for rectifiers into AC and DC. This is one of the projects that we are going to do in this class. All right, the rectifier. I'm going to explain later what is that project. Okay, ceramic capacitors is the ceramic, the capacitor that I explained before. It's basically a sandwich of metallic conductors with ceramic material. The ceramic material in this particular case is the dielectric material. And the air-conditioned capacitors, star capacitors, round capacitors, Those are the bigger capacitors that are used in AC, air conditioning equipment, and AC motor single phase. And those capacitors normally are specified in microfarads.